Hello, my name is Jo May Sika, and I'm here to share my project with you called Engineering a Point Absorber, an Inside View to Wave Energy Extraction. I first designed this project for my Chemistry in the Community class when we cover renewable and non-renewable energy sources. I took the lead and followed our local Oregon State University because I wanted to make this relevant to my students. Their engineers and marine scientists are working together to design and test point absorbers off the coast of Oregon. In order for my students to understand how a point absorber works, first they will have to understand how an electromagnet works. I will demonstrate this to them by taking a nail, wrapping it in copper wire, and attaching it to a power source. This will generate a current in the wire, which will then create a magnetic field within the nail that was not there before. Students will spend the rest of the time that block investigating what affects the magnetic field, whether that's the length of the coil, the number of coils, or the diameter of the coil. The next step in the design process is to introduce students to Faraday's law of electromagnetic induction, which is the opposite of what they just learned last block. This will help them choose one of two ways to design their point absorber. In the first example, we have to have the magnet attached to the seafloor with the coil moving up and down in order to generate that electricity in the coil to be transferred to the coast. Here, in the opposite end, we have the coil attached to the seafloor and the magnet attached to the float moving up and down with the motion of the waves. Last, students will generate and make their own point absorbers, similar to the one shown here, and then we will test them in our classroom wave pool. Hopefully, they will create enough electricity to light up an LED.